And welcome to Desk of LADYADA.
Hey everybody, welcome to my desk of fun. It's a Sunday at around LADYADA o'clock.
Yeah, it's Labor Day. We're laboring.
We're laboring.
We have a bunch of product stuff.
Yes.
We have a cool app we're going to show from Maxim, and we have Digi-Key Great Search.
We got a lot going on.
Let's jump right in because we got a lot going. And then as soon as we're finished with Desk of LADYADA, we're working on a bunch of cool stuff that you're going to see all during the week. So
yes.
Big week ahead.
I had to clean off my desk. Okay, so first up, we're going to kick it off because it's Sunday. It's a STEMMA Sunday.
Yeah, we're celebrating over 50 STEMMA boards already. But LADYADA, you probably have another STEMMA that you're working on, right?
I am. So let's go to the overhead and let's take a look at it. So the STEMMA that I worked on over the weekend is the BNO 080. Hold on a second. Great. The BNO 080 is a kind of collaboration between Hillcrest Laboratories and Bosch. It's a, I think it's a BMX 055 9-DOF sensor, accelerometer, magnetometer, gyroscope, along with a SAM-D20, which is basically like the little sister of the SAM-D21 that's so popular in our boards. And that chip does sensor fusion and interfacing to, like, instead of just getting raw accelerometer data, you get actual orientation vectors, which is usually like annoying math and calibration stuff that people don't want to deal with, especially when you just want to get like your VR project up and running. So that's the chip in the center. And this is like a plug-and-play board we made. It's got a crystal, it's got a level shifter, and a regulator because it runs on 3 volts. We want to make sure people can use it with 5-volt chips. This is a great match for like a 5-volt Uno, which doesn't have enough memory to do sensor fusion and orientation calculations, but it can just read the data off of this chip, which is kind of nice. It's got 2 STEMMA QT connectors. These are quick compatible. Shout out to Nate at SparkFun for inventing it. It was a great invention. And one thing that's neat about this sensor is that it supports not only I2C, which is what we use for STEMMA QT in general, SPI, which I really like because it can be used by single board computers and you can bit bang. That's kind of a nice thing about SPI. And it also has UART. And UART is usually not my favorite like protocol serial. I'm not a huge fan of serial for sensors, except that it is the only thing that you can connect up to a computer, like a PC or Mac or Windows. There's not really a super easy way of connecting I2C or SPI devices. We have these little adapter boards, but serial is actually natively built in. So you can use an FTDI cable. I've got one here, and they've got power, ground, RX, and TX, and you can plug the sensor in. And so I was working on decoding this SHTP protocol from Bosch, and it's kind of like a very interesting protocol, which means it's like a bit quite complicated. And I was like not quite getting the data responses I was expecting. I was not sure exactly like why I'm like, so I'm trying to just do a soft reset. It's not really soft resetting. And I was kind of a couple hours in, and that's when I started realizing, okay, if I can't figure out a protocol, what I should do is I should try to reverse engineer a working setup. So I did a little bit of Googling, and let's go to my computer. And from looking around and looking on Digi-Key, I found the FSP 200, which is the Hillcrest, that's again the maker. They make a dev board, and the dev board has the BNO 080, that's like this chip over here, this rectangular one. And on this little adapter, which you can see here, and soldered onto a USB to serial converter. And then here's a little switch. There's 2 different UART modes, and SHTP is the one I'm trying to decode. And I was like, oh, this is cool. This is kind of what I want. And then, I would use their eval software, and then I would just like sniff the connection. And these are like $90, which I was kind of like, okay, if I can't figure it out by Tuesday when Digi-Key's back open after Labor Day, I'll order this. Is there somebody has a question?
Yeah, how many can you put on a I2C bus?
2.
Okay.
Which is one other nice thing about SPI. With SPI, you can put infinite because you just have a chip select line for each one. Okay, so, I was like looking at this thing, and then one thing I recommend, so people always ask me like, LADYADA, why do you run Windows? Like, why aren't you running Linux or something?
Yeah, one time some guy emailed and said since the elevator that you take to your desk at Adafruit, the source code's not available, we're not an open source company, open source hardware company. So, are you mean it like that, or do you mean it just like generally speaking?
Like generally speaking.
Oh, okay, sorry.
But I run Windows 10, which I actually quite like. And the reason I run Windows is because when you're doing electronics, eval software for chips and development software for chips is always Windows only. In fact, you sent me an article about the early iPod development that used the ARM toolchain, and it said like they all had to use Windows because like there was no ARM toolchain for Mac at the time. So I went and I found this tool. It's actually in Python. It's kind of cool. It's like in Python and Qt. It's like there's like 5 bazillion files, but it actually is kind of a nice little like Motion Studio. It's their eval software, and you plug in the board and you can see there's a couple options here. I can do the FSP 200 SHP or just I don't know. I guess this is like some other dev board or something, and then there's the SHTP and RVC, the 2 ways of UARTing. And I was like, well, I looked at the data sheet for the SHP, and it's like, oh, the chip is an FTDI chip. And I was like, well, what if I just like grab one of my FTDI cables? I've got like a bazillion of them. And I wired it up, and it actually worked just fine. So when you click SHP Connect, you can say, it says like open success, FTDI adapter board found. So thanks to SIVA for not being like weird and like having a special VID PID lock. Like they're just happy with any FTDI connected to this chip, and then you can start seeing like the data being transferred back and forth, and this is like packetized. What you can do here is then like request data, so for example getting the firmware version, and that's usually the first thing you do after you connect to the chip. Okay, so I knew that the chip was working, the breakout was working, and I could connect over UART. So the next trick is you want to sniff the serial connection, and there's software, it's not free, called like Serial Port Monitor. And this is actually one nice thing about Linux is there are open source serial port monitors. You can also connect just 2 probes from your SALI or other logic analyzer, which I did before I remembered that I had this software. And you can see, one nice thing about these software is they do show you like all the hex data being dumped, and they show you written and read data, so you can see like, this was what I was missing. I had to send this 557E07E to kind of like wake up the sensor a little bit, and it responds with 7E00017E, and then I can start sending, this is like the reset command or something. So it was really nice to have this data to look at while I wrote the driver, and then when you start doing matchy, it's like you send the same data as it sends, and you should get their same response. And that was it. I mean, like, it actually worked pretty well. And then what's another neat thing is there's this, like, virtual object. And let's see if I get this. Sorry, geomagnetic rotation. You can see the, as I rotate my hand here, I can make this sword move.
Yeah, I'll get it in overhead real quick, too.
Yeah, so I'm twisting this.
Here, put that in frame. You can kind of...
Oh.
Yeah, move it up a little bit. There you go. Look at that.
Yeah. So this is kind of neat. So this is a trick that I have done many times. If there's a sensor that has UART, they almost always have a dev board that has like a serial converter chip, the chip itself, and some Windows software that you run, and then you just sniff the UART data. I did this to develop the fingerprint sensor library that like everybody in the universe uses. I just ran this weird software from the Chinese company, and then I just sniffed the connection, and then I used that to build out the library. So this is a common thing. I2C, of course, in SPI you can also sniff. It's just you usually do have to have the hardware dev board. Whereas what's nice about UART is like you just use any USB serial cable. So that's LADYADA's tips and tricks for hardware development and reverse engineering. It's an easy one, but if you don't know about it, it's a good trick to know.
All right, cool.
Okay.
All right, next up, we got 2 more things. So, analog mobile app. This is from Maxim. It's called the Essential Analog Mobile App. You get insights on the go, and we did a review. You had a specific phone for testing. We partnered with Maxim, lots of large electronics companies and component makers, and integrated circuit makers are making their own apps, and we teamed up with them.
I want them to do a good job.
Yeah, we teamed up with them and we said, hey, like we're gonna take this for a spin. So here we go.
There's free stuff in it for you.
There's free stuff. So watch.
We'll be back in like 7 minutes.
Yeah, we'll watch our overview of all the things the app can do, and then we'll see on the other side. We're gonna do great search, Digi-Key. Okay, LADYADA, Maxim has a new app called Essential Analog, and this is a really cool app because we're seeing electronic component manufacturers say, hey, lots of people use mobile devices, so let's make an app for them so they can find all the different parts. So this is called Essential Analog, and
scan that QR code.
Insights on the go, available for iOS and for Google Play, Android. And there's a link there, and you can also just hold up your phone right now. That makes it super easy. And through the marvels of modern video recording, we're going to go live to a phone that's on LADYADA's desk. So let's see what's here.
Okay, so I'm going to launch my my Maxim app. Maxim told us, hey, check out this app, do a review, try it out, tell us what works, what's great, what isn't, and then also let everybody else know about it. So we're like, absolutely, we will do that. And bonus, if you watch this video, you're going to get some free stuff. Now, who doesn't love free stuff? Lots of free stuff to be had in this app. One thing you will need before you can do a whole bunch of stuff with the app, you don't need a Maxim account, but if you make a My Maxim account, once you want to purchase or sample stuff, you'll want to be logged in, which I've done here, which is why you'll see me just skip straight to the checkout page. So let's start with the newsfeed. So this is kind of, to me, this is the most interesting because I really like seeing the NPIs, the new products that are coming from each chip manufacturer. I subscribe to the RSS feeds, or in this case, I subscribed to the news feed. There's videos that you can play from within the app that demo the latest eval boards, the latest chipsets, and there's a lovely eval engineer, a design engineer who will take you through the process.
Welcome to the Design Shop.
I also like that
Henderson,
there's closed
and I'm here
captions
at
on these.
Maxim
That's pretty cool.
Today, I'm
not going to play the whole video, but feel free to check out. There's a couple different, there's half a dozen different videos available with the latest eval board. So if you have time to kill and you're I want to see what's the latest videos, check that out. There's also app notes. So app notes are a really good way to get a sense of how to use the part in the most efficient way. In this case, Maxim does a lot of medical, wearable, low power electronics. So this app note is about quiescent current in buck and boost converters, and they kind of talk about the history of buck converters and all that good stuff. And then you can see using the pinch I can zoom in. The feature part for this app note is the Max 17222, which is a pretty cool boost regulator because it can go down as low as 400 millivolts in, which is really nice. I mean, you can run it off of a nearly dead AAA battery, or more than dead AAA battery. So I'm interested in this part. Okay, so what do you do? Well, I just point at it. I click it, and it actually takes me to the Maxim website where I can then do stuff like download the data sheet, and then I can look at the specs in more detail, like what the pinouts are and voltage in and current and quiescent, all that. I can check out more specs here. There's also design simulators and stuff. You can subscribe. So for that, you do have to log in, subscribe, and that way, when there's updates to the product, you will get notified. I use this to get notified when there's new datasheet updates. And then, of course, my favorite is you can also order it. So from here, you can buy or sample. Now, for beginner engineers who don't know this, Maxim is great about sending free samples of chips. If you see a chip and you're I might want to use this, just get the sample now because it's free. They'll ship it to you in a couple days. You can get up to 4 pieces of each sample. And then when you're ready to use it in your design, you don't have to dig around and try to find out how to get the part, especially if it's out of stock somewhere. So I always recommend engineers sample as much as you want. I did when I was a student, and I saved hundreds and hundreds of dollars. You can also purchase from here. So that's, going from app note to product to sampling to purchasing. So that's, one way to use the app. other than the news feed, you can go to the main menu, and here there's kind of like everything it can do. Now, we just showed you, you can order parts through the product page. There's also like a hot link here. You can, put in your favorite Maxim part, and you can purchase directly from here. So they'll give you detailed pricing, and then of course you can also sample. And remember I said there was free stuff that you could get. Well, there's this free analog toolkit, and there's a video about it. I think it has like 30 different analog components. It's like CAN bus and boost converters and isolators, all that stuff. This is free if you register on the Maxim site and
view a package option.
Through the app here, click sample. You'll have to log in with your account, of course, because they need to know your address, where to ship it. You can get this essentials kit for free. So look at all this free stuff you're getting. Free app, free stuff. Other than that, you can also look for parts by type. Like, for example, let's say I want to look for an audio amplifier. They have some recommended ones. If you star these, like you hit that little star button, when you go to favorites, it shows up in your favorites. So that bottom right favorite star thing will let you quickly get to that part. This is good if you're using the Smart Selector, which is, like on a website, normally on Maxim, you would say like, okay, well, I want, let's see. Whoops. I want to, get a boost converter, and then you filter, and you say, well, I have to make sure, I want it to take between 5 volts and 2.5 volts, and I need it to give me, at least 3 volts output, and I need about, 200 milliamps output. When you search and you get all your options, you might star the ones as you're going through them. And then, look at them in detail later when you want to look at the data sheet. So just go through and star which ones you want. So that's using the filter. And okay, so going back to the menu, there's also the app feedback and contact us. So if you're using this app, it is new. If you see stuff you want to see improved, click on the contact us to get more details. There's also a profile and a leaderboard. So the leaderboard, I think, when you watch videos or order samples or look up data sheets, you get points. And hopefully if you get to the top of the leaderboard, they give you more free stuff. But I don't know what the prizes are. But you can check out leaderboards, and if you register, you'll be added if you'd like. So I think that's it. Oh wait, there's one more thing. I want to show the cross references. So this is kind of handy. Sometimes I want a part that's similar to another part. But maybe it's discontinued, or I want it from Maxim because I really like the Maxim quality. So let's say I want a Maxim ADC, and I'm used to using the ADS series of ADCs. You can type in part of a part number. So I don't type out the full part number. I just typed in the first 5 digits, and it'll say, okay, well, if you're using the ADS 1146, you might be interested in the Max 1415. So this is kind of handy, especially people who watch Desk at LADYADA know I say always get multiple sources for your components. So if something happens to your supplier or it's unavailable, the lead time is really long, you have an alternative. So this is a good tool for that. And yeah, I think that's it. So check out the app. Don't forget to get the free stuff. Go to the toolkit. Register and get these. I'm going to click sample as soon as we're done here. I'm going to get that free stuff. I love free samples, and Maxim has an excellent sample policy and sample program, and it's what made me an engineer. Believe me, I got a lot of Max 232s when I was in college to get started with my microcontroller boards. So check out the app. It's free, available for Android or iOS. It was really easy. I installed it, and I'm going to get some free parts.
Yeah. Okay, cool. Well, all the best of Maxim to go. Thanks so much, LADYADA.
Yes. And thanks, Maxim.
Okay, cool. I'm going to post up that video as a standalone video on our site so folks can check it out. All the links are there. You can hold up your phone, the QR code if you want to try the app out. And special thanks, Maxim. we're going to continue to do more app reviews, more reviews of things that are in the electronics world. And as always, on Desk of LADYADA, we have the Great Search. The Great Search with Digi-Key is here.
Yay!
Okay, what are you searching for this week, LADYADA?
Okay, so we chatted about this 9DOF accelerometer magnetometer gyro from Bosch that I'm working on a STEM QT board for, and that kind of got me thinking about accelerometers. And I thought, accelerometers are a really common sensor that people integrate into their project or product. They're very inexpensive these days. They're quite powerful, and they can be used to sense a lot of things like motion, tilt, shaking, tapping. Accelerometers kind of do it all, and I thought it would be good to show the different kinds of accelerometers you can get on Digi-Key, because there's a lot of them, and an interesting way to also export data from Digi-Key for more analysis. So let's go to Le Computer. Okay. So we'll start by first talking about what kind of accelerometer we're going to get. I want a surface mount accelerometer that can solder onto a board. I want one that can be interfaced with my microcontroller or whatever host processor it is. I'm going to assume it's a 3.3 volt device, although there's a couple accelerometers that can be used in a very wide voltage range. I'm going to look at both analog and digital accelerometers. And I'm also going to show sorting by price and some of the extras you can get in accelerometers, because they're kind of stuffed full of extra goodies these days. So the toughest part of this is actually a spelling accelerometer. There's 2 C's, 1 L. And there's a lot. There's also a lot of dev boards, accessories, and such. But I want the sensor transducer, motion sensor, accelerometer. There's also different kinds of motion sensors like inclinometers and vibration sensors, but in this case, the motion sensor I want is an accelerometer. As always, I'm going to go straight up for the active parts only, and I want ones that are normally stocking. That they may not be in stock today, but in general, they're in stock. And I want RoHS compliance, which is pretty much all of them anyways. Okay, so next up you can pick axis. There's dash, which usually means uncategorized, X, XY, XYZ, and Z. Accelerometers used to come in single axis, and if you look at these, you'll see some of these are really old school style analog accelerometers. These are not used by most people. Some of these are mil-spec, that's why they're expensive. Some of them are 500G. In general, you're not going to want a single axis accelerometer. As you can see, the prices are quite high because they're very specialized usage. You'll still used to, when you had an accelerometer with single axis, if you wanted multiple axes, you'd actually have to get 3 accelerometers and solder them with 90-degree orientation. It was kind of horrible. We're just going to go for the triple axis, X, Y, and Z. I also like to always include the dash. Sometimes the dash is from really old products or products that maybe it's unclear what the data is. I like to include them anyways, although I almost never end up picking those products because it's usually some weird outlier. But in this case, I'm just going to apply these filters. Okay, next up, you can start to see okay, I got these accelerometers. I'm going to pick ones that are surface mount, which is most of them. There's also free hanging. I guess it's that's some sort of module. And lost myself. There's chassis mount. What are those? Oh, so chassis. This is an all-in-one, integrated accelerometer module. This is not a raw chip. Wow, this is $4,000. There's some nice expensive things on Digi-Key. I wonder what the most expensive thing is. I think it's probably an FPGA for military usage. It's kind of my guess.
Box of RAM.
Box of RAM. Okay, so but back to this. I want a surface mount. I'm not ready for the $4,000 module. Okay, so type and type kind of goes with output type. So in all honesty, every accelerometer is analog in the bare details. It's a flexible MEMS kind of like finger joint that moves up and down with acceleration, and then the capacitance of that changes and it's measured through an ADC. But sometimes they toss the ADC in, and that's when you get a digital type. If you want an analog voltage output, which some people really like them, actually we sell a couple and they're quite popular. One thing that's nice is that you can get them with so there's a 200G one, but they're usually ratiometric. If you have an ADC, you can of course sample it as quickly as you want. Analog Devices makes a popular series, the ADXL series. STM also has them. I don't see people using analog accelerometers as much anymore because they have ones that are built in digital, but there are some situations where like maybe you do want to have it integrate with an analog circuit, so there's no like digital reading. For example, you could have a tripwire circuit, like a shake detector that looks for an absolute voltage change, and then that gets latched and triggers some circuit. It might be less expensive and might be more reliable if you just have the pure analog output, because there's no like configuration and setup and like initialization required. You turn it on and it instantly works. So analog does have some uses, but in this case I'm going to go with I2C or SPI. I want a digital output. Next, check out the voltage. With sensors, I've been trapped by this. I've been tricked. I see a sensor I really like, and then I don't notice until it's too late that it doesn't run at the voltage range I want it to. If you're using 1.8 volt electronics or 3.3 volt, you want to take a look. Make sure that it either can do both, but it isn't one or the other. For example, there's 3 of them that are 1.8 volt only, and there's 3 that are only up to about 2 volts. And 9 that don't go past 2.7. So if you want to make sure that it runs at 3.3 volts, I usually select all and then like control click to deselect the ones that won't fit. Now you'll notice that there's none that are 5 volt. There's 5 volts. There might be 1 or 2 analog ones that can run at 5 volts, but these days they're all going to be 3.3 or 1.8. Okay, next up, acceleration ranges. So likewise, there's actually kind of like only 2.5 ranges for accelerometers. There's either the like 16G and below, 8 to 16G and below, the 40G, and then like the 100 plus Gs. So 100 plus Gs is if you're dealing with like massive shock detection, like rocketry, like explosions. I don't know, something. 100G is like a huge amount of Gs. So if race car stuff, if that's what you need, it, and you should get those. We do sell a couple 100G accelerometers, but for the most part, if you're just detecting like user motion, you're gonna want to stick 8G and below. Often, user motion doesn't really even get above 4G. Again, 1G is just normal gravity. So think, do things really accelerate more than 4 times the speed of gravity? And then for sports, like humans bumping into other humans at high speeds and high masses, for those you're going to want like 16 to 32 Gs. That's what usually like sports activity accelerometers are for. In this case, I don't mind having slightly higher than 8G, but I definitely don't need the 200 Gs. So, and you're not going to get ones that both do 200 and 4. Like you either get like the 1, 2, 3, 4, 1, 2, 4, 8 range, or the 100, 200. So again, select all, and then use the control key to click away the ones that are, way higher than I'm expecting to use, which is about like 2G. Okay, cool. Okay, there's also features. So here's the deal with features, because they're helpful when looking at sensors, but I always rely on the data sheet because these are very easy to like get wrong or misunderstand. So not that something will have a low pass filter, and this is like a total lie. It's just that there might be ones that do have a low pass filter, but it's like a different kind than what you want. Maybe the low pass filter only like has this differential mode. I mean, there's all sorts of like weirdnesses with each accelerometer. So features gives you a sense of what it does, but I don't use this as a pure way to filter out chips. And then here's another thing that I do want to mention, because as you're looking at sensors, this comes up. Sometimes you're looking for sizes, like when we did the inductor video, remember I was like, oh, I really want it to be less than 4 by 4 millimeters. Well, you're not going to get necessarily like, you do have like the sizes here, but they're not, it's not like written out the same way. So what you have to do is you have to read the package device, and these numbers at the end are the millimeter by millimeter size. So for example, this QFN is 3 by 3, and this LGA is 1.6 by 1.6. And that'll give you a sense of how big it's going to be on the circuit board, and also conversely how hard it's going to be to solder. You want something with the fewest pins in the largest package to make it easy to solder, less yield problems. Something that's going to be, less than 2 by 2 millimeters, or like this CSP, which is, 1.3 by 1 millimeter. That's going to be very, very small, not going to be very hand solderable, or even hot air solderable perhaps. So keep that in mind. I'm not too picky. I will say, I don't really want it to go beyond this size. Like I don't want it to be 4 by 4 or 5 by 5, so I can apply that filter. And then you can just start looking at the chips that are available. And I think, here you can, of course, go by cost, in which case nothing beats this Kionix KXT-J3. The fact that there's 30,000 in stock makes me think, like, wow, the people really do like this. That's a lot of stock to hold of a single sensor. Hard to beat at 51.8 cents, though. There's definitely price wars that occur with accelerometers. This is my favorite, the List 3DH as well. And of course the Bosch sensor text down here. Another thing I just want to note, I don't use this very often, but it's good to have, especially when you want to do maybe more detailed analysis. There's this download table button. And when you download the table, you'll actually get the exported data from Digi-Key with all of the different the data with all the table headers. So in this case, if you want to, if you're good at Excel or, spreadsheet programming, you could, for example, filter out, only ones that contain the word sleep mode or something. Now, for this short list, maybe it doesn't matter so much, but if you have 1,000 items and you don't want to have to page through them, you want to quickly sort them. You might want to sort by, multiple columns in order, like sort by this one and then sub-sort by another one, or divide and conquer. You can use your spreadsheet program. You don't have to use the Digi-Key site. It's got great search and it can do the selection modes, but this data is the same data. So that's another top tip for a great search.
And that's a great search for Digi-Key.
Okay. Whew.
All right, so I'm going to read off some questions.
Yeah.
That came in. All right, so Parallel Logic was looking for accelerometer that was low power and has an external interrupt when the device was in a specific orientation, not just change in orientation. Ultimately, I'm thinking about a ball switch.
A ball tilt switch really works well. They're very inexpensive. They're very reliable. Again, no I2C or SPI, just one pin. There's also accelerometers you can configure for orientation interrupts. They do exist. So, most of these days will have them too. If it's I2C or SPI mode, you're probably going to be able to get that kind of interrupt output. But for that, you have to really look at the data sheet because it's very specific to the chip.
Okay, this one's from Jim. Hey, Jim. Question for the STEMMA QT sensors. Besides the soldering, is there a way to disable the onboard LED for applications with low power requirements or where extraneous light is unwanted?
Some of them have a spot you can cut the LED. I've actually not. I was wondering, would people really be bothered by it? But actually, most people seem to like it because they know that it's been plugged in. You can solder it to remove it. I will say that the power draw is very, very minimal. I have a 10K resistor on it, so it's like well under 1 milliamp of current.
This one I'm just going to pick apart some of the comments that are together. PTC and USB support, that's what I'm leading me towards the SAML series. They're not a fan of the PTC support, would rather all do this in the Arduino IDE. So I think that was something we're looking at. PTC is about half of the PCB. I also like RTC, and everything they'll be doing is a straight C++. Trying to run interpreter on external memory would kill me on the power budget.
I think they're just designing a board in the comments.
Yeah,
I don't think it has much to do with it.
Is there a specific SAML 21 you would recommend?
I mean, use microchip search to find which variant of the SAM series you like. They're all going to be, very similar. Anything with the SAMD or SAML series, they kind of share the same core, same peripherals. So you can kind of go between them. Some have USB, some are 5 volt, some are low power, some whatever. Just find whatever the closest one that you like. Okay. And you should be happy.
So it says, I know this is off topic. I really want to build my own power supply, but I don't know how. Do you recommend me to just buy one? Some recommend a desktop power supply unit. Do you have any recommendations, LADYADA?
You can get like one of those breadboard power supply kits. Like we have one, and that's adjustable. You can grab an old PC power supply and then use that if you just need like 5 volts and 12 volts and 3 volts. You can build your own. I wouldn't build these days. I wouldn't build one with a transformer. Like I kind of did that in college, and now it's like very weird and archaic. Like we don't really do transformer-based power supplies anymore. We also have in the shop what I like these plug adapters, and there's a switch on the side, and you can select different voltages, and that can get you pretty close. So if you need something adjustable and you don't want to like spend the money on an adjustable power supply, there's a lot of hacks you can do to kind of get. It's like, I kind of need about 5 volts, I need about 9 volts, I need about like 4.
Okay. How do you choose between these parts to make a breakout board? Popularity, features, price, magic?
It's a little bit of price, a little bit of features. I look for, there's like infinite accelerometers, right? So it's like the only reason I would make another accelerometer breakout, which I'm probably not going to do for a while, is if it was like significantly higher quality or significantly more capable or significantly lower cost. Like when we started, we made breakouts for like the analog triple axis accelerometers because this was the only thing there's only one. It was like the ADXL335. That was it. And then lo and behold, analog made a digital one called the ADXL345, and it was like amazing. And then like there was the MMA series, which is like it was I2C, and it was like 14 bits. It's like it was more precision. And then the List 3DH came out, and it was much lower cost and had like tap detection. And then I saw the MSA 301, and I was like, that's even less expensive. So it's like it's a little bit of like cost is a big one, but I'm not going to make a breakout for every accelerometer. It doesn't make sense. Like I actually looked at the BMA 456 recently, and I was like, well, like, should I make a breakout for it? It has a pedometer. But then I already had a breakout for the LSM 6DS series of accelerometer gyros. And even though those are accelerometers plus gyros, they're about the same price, and they have a pedometer built in. The pedometer works really well. So, like, it has to be significantly, there has to be something extra for me to think it's worth it.
Okay. Someone points out that JLC PCB has design services. We've not tried that out, of course, but let us know how it works out. A couple people that I see in the comments on a regular basis, let us know if you're going to try it out.
I have not tried design services. I'd like to do my own laundry. I don't like laundry services.
Well, you're a different case, obviously. You design PCBs for a living.
I design PCBs, so I don't know how I feel about somebody else designing
Of course, but it's cool.
But it is cool. Look, if it works, saves you time.
On accelerometers, the person was reading through the data sheet. The interrupt on orientation tended to be change like 12 degrees from one position rather than wake within the device is only within a range.
Yeah, it's tough. I mean, like, there often are, like, interrupts built in, but the interrupts are like you get to only choose, from 12 different built-in interrupts, that are usually a certain amount of change in, some time, or an amount of motion, or an amount of no motion. But there's it's not usually customized beyond that. You can wake up every few seconds and take measurements. It's another thing to do.
Okay. If you want to do low power but with some QT breakouts, do you know a way to control the 3-volt line to these breakouts so when the microcontroller sleeps, the sensors do too?
Yeah, connect the 5-volt, the power pin, to a microcontroller pin. If you're using, most of our sensors will run on 10, 20 milliamps, and a microcontroller pin can source that, so you can just power it directly from a microcontroller pin. It's a little bit not kosher, but works fine. I do it all the time. And as long as your sensor chain, everything on the I2C bus is less than 10 milliamps, I think it's perfectly fine to do. Okay. And you absolutely cut down all the power. There's no worry about quiescent current at all.
And that's our Desk of LADYADA tonight. Don't forget, this Wednesday is CircuitPython Day 9/9/2020, celebrating the biggest and best Python on hardware community,
Yay!
I think, out there. Thank you everyone who contributes.
Everyone's welcome.
Part of it and more. We're going to be doing stuff all throughout the day on
That's
Wednesday,
right.
9/9/2020.
Blinka folks are also welcome. Raspberry Pi users.
Yeah.
BeagleBone, NVIDIA Jetson, all y'all Linux folks, you're using CircuitPython too. If you're using our libraries, it's CircuitPython.
And we have hundreds of boards in circuitpython.org/downloads. About 50 or so in Blinka. We got 50 or so STEM. We got thousands of Feather and Featherwings. We got a lot going on. And we'll see everybody during this week. Bye, everybody.